Hello everybody, nice to meet you. My name is Boy Maas and I'm part of the Jamzig team, which is now coding actually like Jam, let's say the node in Zig. The team now consists of one person, it's me actually coding. And we also met Risa. She's part of the team, but she does more, let's say, the social side and the business development side of the project, which probably happens later, right, in the phase. So let me introduce myself a little bit, So I'm Boy Maas, right? I entered the crypto in 2018, where I was starting as an entrepreneur, as a block producer for the EOS network. I don't know if you're familiar with EOS, anybody? It was one of the biggest ICOs in the history of the crypto. I think they grabbed some 4 billion, if I'm not correct, right? And they invested a lot in Bitcoin, right? So they're sitting on a large amount of money. And let's say I was one of the block producers. And let's say I can still remember how I started, right? Because I was living in my apartment and I was a little bit thinking, okay, what am I going to do with my life? Let's say at this point in my career. I say, yeah, well, let's try something in crypto. So I reserved the name EOS Amsterdam. And that was a very good choice, let's say looking backwards, because for some reason, essentially, when you look at the financial world, right, you think of Amsterdam, London, and something else, right? And Amsterdam was very popular, so actually, without doing anything, I became like one of the top 21 block producers. Just I didn't name Amsterdam, right? So that was fun. So yeah, that was my first introduction with actually block producing, and it was a very enlightening experience, right? Because I'm not sure, but that was one of the first delegated proof of stake networks, let's say in crypto. Is that correct, Gavin? Yeah, something like that. But I was fascinated by it, right? Because you have kind of, let's say, a socio-economical game, right? Which you introduce, which can alleviate, like, the speed in which transactions are actually performed, right? And this, like, part of this is also, let's say, involved in the jam design, if I'm correct. So after this, I was a bit disappointed, right? Because, let's say there was promised, let's say, $1 billion, let's say, invested in the development community, but in the end, when we were 2 years in the US, they didn't even have a wallet, So let's say I thought that was not really like, I really didn't appreciate that. So after a while, I left the EOS community, and I engaged in the DeFi sum of Ethereum, where I actually started working with smart contracts, let's say, doing financial like DeFi projects, and this was, let's say, a real eye opener for me, just, let's say, having code, doing stuff with money, right, and having yield, and just, let's say, calling other smart contracts and combining a lot of different elements, right. That was really, let's say, it triggered something in me, right. So from there, because that was around the time that the Uniswap pools came up, right. So I started, let's say, with a friend, we designed this arbitrage bot. We started developing, with the Bellman Ford, let's say, pathfinding algorithms. So we had this big machine, and we injected like a lot of, let's say, fake nodes in the Ethereum network to get as fast as possible the transactions, build our own custom mempool to make some money. And that was, that at that point in time, right, that was actually, let's say, I learned a lot about Ethereum and the working of Ethereum. And I must say, Gavin, let's say you did a lot of stuff really, really well, like little things, like for example, like having a smart contract, which is a unique representation of codes, right? The ability just, let's say, to call other contracts, right, and do flash loans and flash swaps and move money around in one transaction, and then when it fails, you can even do a rollback. That was really like really amazing, let's say, because of, let's say, what you could do. And I can still remember, I was walking with my child, right, and we had this bot running on the background, and then I was walking with him, essentially, like, buying like some fries for him because he's still little. And then my partner called me and said, Jesus, we just made $10,000, in one transaction, That's crazy, let's say, the ability to do that, right? And then you make a swap with like more than $1 million, right? But it doesn't matter because, it's just inside the block, right? It's deterministic. So from there, actually, I went to the Avalanche network, right? Which because I liked the consensus algorithm and Solana, but there you notice, Avalanche of course copied a lot of Ethereum, but Solana, I wasn't that impressed by it, right? Because they say like 12.1 second finality, and all, let's say, but in practice when you really run it, it's like heavy nodes, a lot of bandwidth. So I didn't really like it that much. And then I got hired by TFL. Maybe you heard of them, let's say. It was we had a little bug. Actually, I went to Berlin to the Web3 conference, and I met Daniel, and I said, informed me, it's a nice project, let's say Jam, it's interesting to build. So, I've been building nodes, let's say, the last 2 years, why not? Why not? Let's start working on it. I had no clue what it was yet, I was never really into Polkadot, right? But, let's start building it. So, so that's actually how I ended up actually here, and we're now in let's say Bangkok, doing something. So, so sorry, I just whipped this presentation up very quickly, while I was sitting there, but so in the end actually, so why Zig, so first of all, I didn't know Zig as well, but I heard a lot of good stuff about it by very smart people. So for example, HashiCorp, the guy who did a lot of development on the, let's say HashiCorp, he deposited like $300,000 to the foundation, and let's say the people that are working in it smart, they're very happy with it, and so I thought, okay, let's try it. So why not combine it? So I could implement a node and learn a new language, right? So, and I was very pleasantly surprised, to be honest. But let's say I'm not going to go over all the stuff, but my experience actually is like, he kept his language very simple. Right? So I came from Rust, for example, and I went to Zig. And Rust has a certain philosophy, right, where you actually have a lot of memory control, right? And let's say you have a lot of protection, and you have a type system. It's really hard to make mistakes, because everything is kind of a Tetris. You need to Tetris everything together, and then when it compiles, it works very well, but it's also kind of a strain. You have to know a lot, right? You have to find a lot, but the tooling is very good, and the compile times are very long, right? But Zig is actually doesn't do that at all. It gives you all the freedom, you can do whatever you want, and it has some kind of, let's say, killer feature which is called compile time. I don't know, does anybody know what compile time is?
Compile time?
Yeah, compile time? Yeah, we have different kind of, no? And compile time means actually like, there are two phases in the compilation stage. So one is you generate the code, and you make an AST, blah, 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 intermediate representation, and then you get some output. And then the compile time is, let's say, the first phase of the compilation, where you can actually generate code, right? And generating code by code is, of course, something nice, because you don't have to do it yourself. That's always good. The same with Lisp. Let's say I also program the Lisp, but I always love that, the macro system, right? You have the tree, you can manipulate the code tree yourself, right? And Zig has that capability, and that actually makes stuff implementing, like for example decoding, encoding, a lot of boring stuff actually you can get away. What I also liked about it, right, was Andrew Kelly, right? Because this guy actually, he just doesn't care about anything, He just wants to code, right? He's just like, a creator at heart. He just wants to build great software, right? And that passion actually reflects in his choices, because if somebody, let's say, loves what he does, then of course he puts this also in his work, right? That's essentially how I see it. So the ambition of this guy is crazy, and so I saw this tweet from the Pride Museum, and he said like 10 years ago, he was asking somebody, okay, how do I print something in C++? Can you imagine? Like 10 years ago, he couldn't even print something in C++, and now he builds like, I think one of a very innovative language with very, very opinionated choices, right? So this is very good. So ambitious, speed, control, performance. So everything is geared to performance. I advise you to watch his talk about memory mapping, right? And how you represent stuff in memory really optimizes performance. So, and I wasn't even aware of that. But if you even pack it a little bit together, you get so much more performance out of your system. And when I read this, I really had to laugh, let's say. So he actually is now working on like getting rid of the LLVM, just for compile time. So he wants to because he believes that you want to have fast feedback, right? So you want code fast, compile, and have this creative loop, right? So that's a massive project, no? Yeah? That's ambitious. Yeah? Yeah. Another thing of Zig is also very nice. It's very well imported to different platforms. Yeah? So the tooling is really amazing, right? The build system, which is also Zig. So actually, once you enter the Zig world, everything is Zig. Yeah? So everything is Zig. You don't do anything else, right? So it's really a nice guy. It's a really cool guy. Okay. So to give you a little example of the code. So now you have to report this, of course, because you've seen this implementation detail. But this is kind of an idea, right? So here is this kind of a little function I wrote. Recursive serialized lead key. Now lead key stands for, I'm using an arena allocator because I don't want to keep track of all the memory at once. So I do something and then I allocate it as a whole. And then this is the thing, com time t. And the moment you introduce this, like the code suddenly has two dimensions, right? So one is com time and the one is normal. And on com time you can get everything, right? The type information, all compile time information is available to you, which you can actually use to write something. So imagine a block being serialized, and this would be kind of a block, right? If some field of it would be an int, then this point would exist. So in the final code, you have the definition of a block. This function would run, it would generate specific code just for that block, would optimize it, right? And that would just be executed, right? Which is pretty amazing, right? And it's kind of a little bit more flexible than Rust, in the sense that you can just have this different kind of easier. It's like easier. You're not constricted that much with the type system. All right, so the speed of implementation, because including the learning of the language, I think I started 2.5 months ago, and it was remarkable how productive I was actually. It was like, okay, coding, nice, this, that, blah. So in 2.5 months, I implemented all the test vectors, working, PVM, not the host functions yet, and then actually the eraser coding still has to be done, right? And so it also speaks to how well you can develop actually with a language like that. And it's also funny because there's almost no documentation, right? But you just jump into the standard lib, and everything is just the same. So everything is explicit. So there's no syntax almost, right? So it's kind of really easy to parse, right? In the mind. Okay. So this is the first time I ever worked with a formal specification, right? So that's really an eye opener, to be honest. And what I also noticed, by the way, is there's also a cool thing is that we all now share kind of a little domain language. So suddenly the symbols, because you're like working, and say in the first week I was thinking, what is happening? All these symbols. But then after a while you start parsing it, right? And it's almost like you have this block of symbols, and all those symbols start to make sense. But it's also your comprehension makes sense. So you can suddenly see kind of a formula, but you understand the total structure of it because it's so compressed. Which I must say, it was thank you for that gift, Gavin, because it's a lot of fun actually, to go through it, right? It awakens the brain a little bit. So so brain, so that's what I mean. Your brain needs to be prepared to parse, but once you do it, so that's that. Okay, that was my experience as Jamsik.
Okay, thank you so much.